January 3rd, 2020. Can't believe it's 2020. Let's see. Just wanted to do a short video on some extra details about thermal mass. It was inspired by my friend Josh over at the Citystead by his video on how he just filled 165 gallons, which is three like 55-gallon barrels with water for thermal mass. He's kind of on the start of the learning curve on thermal mass, and I wanted to share some details back with him. But you should go over and check out his channel if you haven't. He's doing some really cool stuff in his yard in Michigan there, and really nice guy and excellent, sweet family. Anyway, really intelligent dude, and you should go check his channel out if you haven't. So he was talking about thermal mass and about the barrel temperatures, a few details on thermal mass systems. So thermal mass basically puts heat out if the temperature of the thermal mass is higher than the temperature of the air in the environment you're using it to regulate, and it takes heat on if the temperature of the environment exceeds that of the thermal mass. So at the end of the day, what you're really looking at is something called delta T, or the difference in temperature between the thermal mass and the air temperature. And so this is where thermal mass plays a dual role, basically, where if greenhouse temperatures, for example, we'll look at this barrel here just to simplify things. This barrel here, full of water, is 55 gallons or thereabouts. At nighttime, when the stove goes off, this barrel temperature is higher than that of the air in the greenhouse, and consequently it's releasing heat into the greenhouse and helping stabilize the temperature of the greenhouse. And that goes for all the thermal masses here that are connected to the stove. And so at night, when the temperature of the greenhouse starts to fall, say the barrel is at 70 degrees and the greenhouse falls to 50, well, now you have 20 degrees of difference. So the more the temperature starts to fall in the greenhouse, the faster you dump heat off of your thermal mass into the greenhouse. And vice versa. In the daytime, when the sun comes out and the greenhouse gets really warm, if it's 80 or 85 or 90 degrees in here, some of that heat energy is going back into the barrel. Obviously, that is not the most efficient way to transfer that heat into the barrel, but it does have a regulating effect on heat exchange, I guess we'll say. So that was one detail I wanted to cover. Let me think for a sec here. Okay, so regarding taking heat from the sun to heat your thermal mass, yes, that is possible, but it comes down to the amount of surface area on the thermal mass and how efficiently you can transfer that heat from from the sun or from the air or whatever medium you're taking the heat from. So obviously the barrel has all of its surface area exposed to the air, and that yields a benefit in collecting some heat. But if you look at sunshine is about 1,000 watts per square meter at full intensity around noontime. Obviously it varies with season and that sort of thing, but you can basically use that as kind of a baseline to understand the concept. So if the sun is shining at an angle like this, then you're only seeing this cross section of the barrel that's hitting it, and only even part of that is perpendicular to the sun, so you're not gathering the most efficiency. However, if you paint it black, it will absorb quite a bit of heat. Now if you were to take that and roll the surface out flat and point it perpendicular to the sun and have a way of exchanging the heat from that into your thermal mass, that would be a much more efficient way to gather it. Now my friend Josh here over at Citystead is talking about using an air, basically it sounds like an air pipe to run through his thermal mass, and that actually probably would work really well. If you combine that with like a small solar panel and a fan that came on when the sun was shining or when the greenhouse temperature went up, he could pipe that air in through those pipes through the barrels and be dumping that heat into the barrels, and then it would be released slowly later over the nighttime when temperatures start to drop in the greenhouse again. So that's an excellent idea, and air is a really easy way to move things. Air leaks aren't as critical as water leaks. However, water because of its inherent thermal mass, and also because of its stratification capabilities, water is a really excellent way to do it also. So water and air both will stratify based on the temperature gradient. Air less because it is less dense, and in part because it's less dense, it flows easier, and so it tends to mix easier. But even air will stratify. You can see a lot of examples of this in spaces where there's a heater without a fan going. You'll find the upper part of the space is warmer than the lower part of the space. And Josh was talking about how the upper part of his barrels were warmer than the lower part. And I have that same thing here. This tank here, for example, runs about anywhere between like 60 and 90 degrees, or even 100 in the top part of the tank. And in the bottom part of the tank, it'll go as low as 45 or 50 sometimes, just because of the way the water stratifies in here. Same in this large thermal mass tank. Now this one is heated with a coil that's inside of this smaller thermal mass, and that collects the heat from the top of the stove basically and pumps it into this tank. Now that pump is set up specifically to pull the coldest water from the bottom. It has a long extension tube on it that goes all the way to the bottom, and that pulls the coldest water. Now again, that's important for a couple of reasons. One, as we store heat from the top down in the tank. In other words, as we heat the water in the tank, this will be warmer up here than it will be down here. And number two, what that provides is the coldest water going through the exchange coil, and therefore once again providing the highest delta T, or difference in temperature, that allows us to capture the maximum amount of heat energy as the water flows through the coil. And so you consequently grab more BTUs out of here and pipe them into here easier. Let me just think for a second. I want to make sure I haven't missed any of the details that I wanted to provide. Okay, I think that's pretty much everything I wanted to say about thermal mass. This video is aimed at helping Josh, but hopefully it will help other people as well. Sometimes thermal mass, if you don't if you haven't really experienced it before, can seem kind of overwhelming and complicated. But once you start to understand some of the scientific concepts behind it, it becomes much more clear and much easier to use and manage and take advantage of. So I hope this helps a bunch of people. A couple of comments. Josh reused bath water from giving his kids a bath to fill his barrels. I thought that was an excellent recycling water technique. So props on that, Josh, and that was his wife's idea, so that was a great idea. Let's see. The other thing, I know he tried using tea candles last year with a clay pot to heat it. But again, with that stratification, you got all that hot air rising to the top of the greenhouse, and so it's not really providing any heat for the plants. I think if you put those candles into some sort of, even over a coffee pot with a tube coming out of it, and did a convective circulator running through the thermal mass barrels, I think those candles would provide tremendous more benefit for the greenhouse, because you'd be heating the water, and that water would heat more uniformly and release slowly overnight. And you'd also gain radiant heat rather than just warm air. And there's a big difference in that too. Radiant heat actually travels and like a light beam, basically. It travels and impacts surfaces and will heat those surfaces through that radiant action. So I hope this answers a whole bunch of questions for Josh and for anyone else who's interested. And if you have further questions about this, don't be afraid to ask in the comment section down below. And if it's necessary for me to do another video, or you want me to go into more detail, I'm more than happy to do that. I hope this helps someone, and welcome to 2020, and thanks for watching the Pharmacy Seeds Network. Okay, I have to edit. I didn't even realize Josh mentioned me in his video until I went back and finished watching it. He had so many wonderful points that he covered that I just wanted to address them before I forgot what I wanted to say. So I paused his video and made my video, or started making my video. But hey, thanks Josh for the shout out, and same back at you. And yeah, I do put a tremendous amount of heat in. It's actually just a regular wood stove now. Originally it was a rocket stove. I have videos on that if you're interested in checking that out. It was actually an in-ground rocket stove furnace. it's a pretty cool thing to play with, and it worked pretty well. I built it out of not so long-term materials for cost, just to test it. It did work well, and at some point in the future I may build some hybrid between the two of these. I kind of built this greenhouse to do a lot of experimenting, just like Josh is doing, to learn about doing a greenhouse in controlled environments. And I, like him, thought it would be easier than it actually practically is. It takes some thought and some practice and some understanding. You're basically heating a space that has zero insulation. So I guess I'll mention a few things I would do. Josh wants to heat his greenhouse entirely passively. I guess one thing I should mention first is, besides wood stoves and electric heating, propane, and all those other options, there is also a way to heat greenhouses with compost, decaying compost, and that works really well also, so that's a possibility. And of course, once again, if you integrate something like that with a Raspberry Pi, you can really manage those thermal parameters really nicely. We'll get into that more later this season. I'm planning to do some upgrades and add-ons to my Raspberry Pi and really harden that interface as a reliable interface. And I'll be incorporating Arduinos with it and a bunch of interesting stuff like that. I know Josh does robotics for a manufacturer for a living, so it'll be cool to see him if he picks up a Raspberry Pi and starts playing with that. I don't know if he'll do that or not. That's up to him, of course. What else did I want to say? There's something else I wanted to say. Oh boy, my mind is everywhere tonight. Yes, that's what it was. The other thing I wanted to say was, if you were to dig your greenhouse into the ground a ways and then insulate the outer, like you dig the greenhouse into the ground, like say 4 feet, and then use insulation board on that 4 feet of soil that you're in, and then slope your ceiling back, and then either pour a concrete wall, or ideally something like ICF, insulated concrete forms, on the back would be excellent, and then you would not have that extra cooling loss exposure on the backside. That would tremendously reduce your heat loss. So there's a few things that are going here when you do thermal mass, and especially if you're doing passive heating. You want to collect as efficiently as possible and reduce losses as much as possible. And so doing something like the back wall like that and recessing the ground and insulating gives you tremendous advantage. And remember, once you go down about 4 feet in the ground, at least where I am, the ground stays around 45 or 50 degrees year-round. And I did actually have soil temperature sensors in, and I probably will put new sensors in deeper next time around. But I also have a couple of videos on that worth checking out to see how the soil temperatures fluctuate. Anyway, so there's many pieces you can take advantage of there, and it's really about increasing the efficiency of taking on heat and decreasing the efficiency of losing heat, basically. So those are my points, and I think I'm finally done babbling. I hope this helps someone, especially hope it helps Josh, and hope you have any, out thinking my mouth. I hope if you have any questions or comments that you put them down below, I'll be glad to address them. Alright, thanks for watching the Pharmacy Seeds Network. We'll catch you in the next video.